let's look again here. I'm going to compare two consumers. One is the consumer that really consumes very little, just in this first block. That's the pink customer. And the second, these blue squares, is the customer who consumes something like 230 or 240 cubic meters a month. The pink customer receives an 80% discount on each unit consumed over some, say, 10 or 20 cubic meters a month. So the pink area there is the total volume of the discount received. But then if you look at the 230 cubic meters a month household, that household not only receives the same discount as the first household, but also receives a discount on all the other units consumed. The end result is that a smaller discount over more units of consumption actually equals a total larger subsidy. So the monthly value of the subsidy that goes to the second consumer is much larger than the value that went to the first consumer. Because of this, increasing block tariffs provide the largest subsidy to relatively large customers. The exact difference between a small customer and a large customer depends on how the tariff is shaped. But making changes to the tariff doesn't make as much difference as you might otherwise expect. I'm going to talk here first about two different kinds of changes you might be able to make to a tariff. One is to try to reduce this general subsidy. I already said that most IBTs come coupled with a general subsidy to all. What happens if we raise the price in every block of the tariff? What you see here, so that's what I've done in this graph, you see though that the same pattern still exists. The subsidies that each customer receives might be smaller, but still the larger volume customer is receiving a larger subsidy than the pink subsidy for the small volume customer. It's only customers that consume more than 300 cubic meters in this case, in other words, to the right of my line, who would start to pay back the subsidy that they received. All users in an increasing block tariff situation receive the discount for the early volume of consumption, the early units of consumption. And for that reason, it tends to be the larger volume customers who get the largest discount. Another thing that you can do, not just raise the price, but you can also shorten the tariff blocks. So rather than having the first block, say, go to 100 cubic meters, we can make it go to 25 or 10. Yeah. So here is an example of, with some simulations that were done, to see what would happen to the size of subsidy received by different households if we change the size of the tariff block. The first one here is a case from Bangalore. We have an IBT where the first block is 25 cubic meters, and the second is what might be called an improved IBT in the sense it has a lower or a smaller first block, in this case only 18 cubic meters. In the right-hand column is the ratio between the average subsidy that goes to the poor households and the average subsidy that goes to all households. And so ideally this number should be greater than 1. If we want poor households to receive a bigger subsidy than all other households receive on average, then this number should be larger than 1. In the case of Bangalore, you see it's less than 1, so poor households are receiving less than everyone else on average, and changing the IBT doesn't make very much difference. Reducing the size of the first block doesn't make very much difference. In the case of Paraguay, which is the next one, this is a simulation done on all households living in urban Paraguay. Here we have IBT with even smaller first block, 15 cubic meters, and then in the improved IBT it's only 5 cubic meters. Here we see a larger difference. So still in the first case of 15 cubic meters, the poor are receiving a smaller discount than everyone else. Once you go down to 5 cubic meters, which is very, very small, we end up with a situation where the poor are receiving the same size discount as everyone else. Now I've also, just to not only talk about increasing block tariffs, I've added a few other tariffs here for you to look, for you to see. The case of Bogota, it's an increasing block tariff but also combined with geographic targeting, so that those who get the largest discount are those who live in neighborhoods we think are poorer. In this case, the poor get slightly higher, slightly larger subsidy on average than the non-poor, just a little bit above 1. The same is true for the case of means-tested discounts in Chile, where if you qualify for the subsidy, you get a discount on the first 15 cubic meters of water used each month only. In this case, again, the poor get slightly larger subsidy than the non-poor who qualify for the subsidy. And finally, the last one was a simulation of a slum area discount. So this would be a geographically targeted subsidy for households who are living in slums and where everyone else is paying average cost pricing. So anyone who lives outside the slum is paying full cost, say. In this case, we end up with poor households receiving a discount that is 17% larger than the average subsidy provided to everyone else. So you do see there is some possibility for improving or reducing, say, the difference between the subsidy that poor households receive and that non-poor households receive by changing the increasing block tariff structure. But it's small. The difference is small. And we still don't end up with a case where the poor are getting a lot more discount or a lot more subsidy than everyone else. The other cases here with geographic targeting and means testing do better, but still we're not talking about huge differences between the subsidy poor receive and the non-poor receive. Finally, let's bring it all together and look at benefit incidence. So benefit incidence looks at the total value of the subsidy that's provided and asks who is receiving the majority of this subsidy. Again, looking at the same cases that we just described, I'm going to look here at an indicator of benefit incidence. And this indicator is measured as follows. It's the percentage of the subsidy that's going to poor households divided by the percentage of population that is poor. So in the case of a totally neutral subsidy, where everyone got the same subsidy, the value of this indicator would be 1. Right? Everyone gets it, so the amount of the subsidy going to the poor is exactly equal to the percent of the population that is poor. That would be like a neutral subsidy. That would be 1. If it's less than 1, it means that the poor are getting a smaller percentage of the subsidy pie than they are of the population. That's regressive, so that's bad. If it's greater than 1, then the poor are getting a larger percentage of the subsidy pie than they are of the population. So they're getting an advantage in that case, and that would be progressive. So if we look here at these numbers, greater than 1 is good, less than 1 is bad. Here we have, for the increasing block tariffs, the first 2 examples in Bangalore. In both cases, the poor are doing worse than they would with just a neutral or randomly distributed subsidy. In the case of Paraguay, we're close to 1. So the poor are almost getting as much as we would expect them to get in a neutral subsidy situation. Once we improve the increasing block tariff and go down only to 5 cubic meters for the first block, then they're actually doing better than everyone else. So the poor are getting a larger percentage of the subsidy pie than they are of the poor population, of the total population. Likewise, in the case of geographic targeting in Bogota and the means-tested discount in Chile, here again, these are progressive subsidies, although not so progressive, for example, in the case of Bogota. And finally, the slum discount that I described in Kathmandu is again a regressive subsidy. Still, most of the benefits are going to the non-poor.